Hi there guys, this is the follow-up video to the Perodua stroke Daihatsu timing belt and tensioner change, where I'm going to demonstrate the use of the timing belt tensioner tool for any of you that are planning on buying one or have bought one and are a little bit unsure on how to use it. For those that are familiar, it has similarities to the Facom tensioner tool I used in my Ducati belt video. That particular tool was borrowed, not my own unfortunately, so while that was very simple to use, I wasn't able to utilise that one again for this particular job, and wanting something similar, relatively easy to use, this was by far the cheaper option. The Facom tool coming in at well on over £100 to buy, and this particular one can be had for about £18 and upwards on eBay. Now there are more expensive ones. This tool is manufactured by Laser, although this particular one is a Satra brand, as you can see there, but they are all the same in operation. They work the same way. Now this was delivered in a bag and in this box here with no instructions whatsoever, so if this is one of the downsides of buying cheaper tools for occasional use. So it's handy if you can find out how to use these. Now I'll just give you a very brief look at this. You can see you've got a micrometer adjustment knurled handle there, which winds in and winds out accordingly, and then on here you've got a spring-loaded plunger which moves a pointer up and down a graduated scale, and this is how you check the tension of your belt once you've got a couple of readings. Unlike the Facom tool, you do need a couple of bits of information from your user manual, but that's information that should be easy to get hold of. Even if you don't have the user manual for your car, you should be able to find this information in your service handbook or from a friendly car dealer if you phone up and ask them nicely. I'm going to pop this down a moment, and to do this I'm going to be using out of the blueprint box the old timing belt and old tensioner to demonstrate how this works for you, because as you'll remember from the video, if you've watched the previous video, accessing the engine bay was very tight, it was very dark in there, and it was really hard to demonstrate how the tool worked in there when you're having to actually adjust the tensioner, take the reading and try and get a light and a camera in there all at once. You know, nobody has enough arms to do that, unfortunately, so hopefully this will make things much clearer. So without further ado, we're going to scoot over to the bench, show the layout that we're going to be using, and then I'm going to be showing you a couple of parts of the instruction manual. Now we're here at the bench and we've got the timing belt and the tensioner sitting here. So this is going to be representative of how it would be on your engine. So looking at your engine, this is the bottom of the engine, this is the top of the engine. You've got the smaller crankshaft pulley and the larger camshaft pulley at the top. For every 2 rotations of the crankshaft pulley, you will get 1 full rotation of the camshaft pulley. Your tensioner sits over here. So this side is straight between the 2 pulleys. This one moves in and out, which in turn stretches to tighten or slackens to loosen the tension on the belt. The pulley itself pivots on a pin here and moves like so. This little bit here is so that you can lever it either way to adjust the tension. You've got a slotted hole there which a bolt goes through and allows it to move, and then you've got a sealed roller bearing with a smooth face here, so that the outer smooth surface of the belt runs on that. Now all timing belts work in the same manner. Some might run a water pump or a couple of extra ancillary bits and pieces, but they all work on the same principle. It's a toothed rubber belt, very tough, as you can see. Don't do that with a new belt, by the way. I'm just doing that to demonstrate, but you can see it's incredibly tough. It's rubber and textile, and it's all sort of heat bonded and all the rest of it. And they are tough, as I say. Don't do that with a new belt though, that's just a demonstration with this old one. So with this in place on here, we're assuming at this point what you've done is you've taken off your ancillaries, you've taken off the cover, you've taken off your old timing belt after aligning the marks, you've fitted the new one, fitted the tensioner so it's got a little bit of tension and nipped it up so that you can still move it but it holds its place, and then you've rotated the engine a couple of rotations to make sure that it's settled nicely on the pulleys. Next thing we're going to do is take our tensioning tool and fit it to the belt with these two pegs behind on the toothed section and the plunger portion on the flat section, this bit here, making sure that the flat section is actually on this curved portion of the plunger, not on this rear bit, as you can see there, that sticks out. And then these two bits go on the toothed section of the belt. Now we're going to take a little bit of a look at the tensioning tool. Anybody that's worked with a micrometer will be familiar with how this operates, because you've got a knurled nut with numbers on there. What you can see there are large numbers and small numbers. The small ones are not incremental numbers. What they refer to is a scale on the rear of the device, so exactly 180 degrees around from it. You see you've got large numbers on this scale, and on the other side you've got small numbers. So the large zero corresponds to, well, the large numbers correspond to this scale, the small numbers correspond to this scale. You can see you've got a 0 there, and you can see you've got a 0 there. So no matter whether you've got the tool on this way or this way, what you've got is a scale that's easy to read. This scale goes from 0 to 20, and this one goes from 1 to 0, 1 to 10 if you like, and is adjustable, so one complete revolution from 0 to 0 will take you down one notch on the other scale. I'm going to put that to one side for a moment, and we're going to talk about the information that you will need to set the tension of your belt. You will need two pieces of information from your workshop manual, those being the pushing force in Newton meters that's acting on your belt, and the amount of deflection in millimeters of the belt at that pushing force. Now these bits of data will be available from your workshop manual, and what I'm going to do now is show you the chart that we will use with this tool to transfer that data into information that we can use to set the settings on this tool and set the tension accordingly. So I'm just going to cut off here and show you the page with the instructions of use and the chart on, and I'll leave that on there for about 10 seconds or so, which will be enough time for you to take a screenshot of that and print it so you have a copy of it. So now we're back in here, and what we need to do now is take that information and transfer it in such a way that we can use it with this tool. So we're going to assume that the information you've taken from your workshop manual specifies a pushing force between 52 and 57 Newton meters for a deflection of 2 millimeters. So what we're looking for is the belt to deflect 2 millimeters when a pushing force of between 52 and 57 Newton meters is applied to that point there. If you had a Newton meter reading on your finger, for example, and you push that belt 2 millimeters and the Newton meter reading read somewhere between 52 and 57, then you'd be in the right kind of ballpark. That's effectively what this does, because we don't have a Newton meter reading built into our fingers, certainly not yet anyway. So that's what we're doing with this tool, but we need to convert it into usable data on the chart. So what we need to do is go back to that chart that I showed you, and we need to take a look at the load, cam belt load at the top. Now you'll notice this is in DAN, that's decanewtons, not Newton meters, but don't panic. The good news is that transferring Newton meters to decanewtons is incredibly easy, so easy in fact that I can do it, and I'm crap at maths, and that's because 10 Newton meters is precisely 1 decanewton. So that's good news for us. So 52 to 57 is 5.2 to 5.7 decanewtons. Now we'll look at the chart, and you can see the chart here. So we're looking over here, and you can see that we've got 5, 5.5 and 6. So we don't actually have 5.2 or 5.7. So what you do is you go for a figure in between, because quite often this is what you'll see in a workshop manual. So you need to go for a figure in between. If you can get one that's bang on, then that's good. If not, just go for an average in between. That's absolutely fine. So in this case we're going to go for 5.5 decanewtons. So we're going to go down on this scale until we can see the 2 millimetre on this side. Now this goes up in half millimetre increments, so it goes from 0 to 5 to 1, 1.5 and so on down the scale. So we're looking for 2, so we move across on the 2, where we can see it corresponds with the 5.5 decanewtons on the top there. You probably can't see this very clearly, but what we have, the readings that we've got, you have a tension setting and an optimum tension. Now the tension setting is the one that we're using to put on the device, and the optimum tension is what it needs to read on that scale, the sliding scale, and this is where we adjust it with the tensioner. So I'm going to go ahead and apply the tool to the belt as you would if we were doing that. So we're looking for a setting of 16.6. Now you don't set the tool before you put it on. Open it out to its fullest at 20, or even a little bit more at 21 as it were, because this will allow you to wiggle it over the belt, because obviously you've got a little bit of free play there on the plunger. Now I'm going to hook it on this way. It doesn't matter which way you hook it on. I'm just doing it this way so that it makes it a little bit easier for you to see. So you make sure the flat of the belt is on that curve, and you make sure the toothed side is on there. At this point we need to turn this in so it's reading correctly. So it's 16.6 on this scale. So one full turn is 20, another 19, another 18, another 17, and then one more full turn is 16. To set it to 16.6, so 1, 2, 3, 4, 5, 6. That's 16.6. And then you'll notice this plunger will move along this scale, giving you an appropriate reading. Now you'll notice as well, if you look at the other scale, that this is also set to 16.6 because you're using the small numbers and using the large numbers there. Likewise 16.5, 16.5 and so on. So you're reading this off from this side where the actual markings are, so that's at 16.6, and the amount of deflection according to the scale that we need to be looking at is, if we just have a double check on this chart for you, so we've got 5.5 and 2, 16.6 and 14.5. Now we're looking for a reading of 14.5 on this sliding scale. So the tension for a 2 millimeter deflection is right up here. And as you can see, I'll try and get that on so that you can see it. So right up there, and as you can see, that's quite a lot of pressure because it's obviously very little deflection. Now let's just assume that this belt is very slack and it's reading currently about 5.5, as you can see there. What we need to do now is push the tensioner in that way, which will pull the tension on here like so, and move that plunger up, and then the pointer likewise will follow that. So you pull that and tighten it and tighten it and tighten it until that plunger moves up and up and up and up and up, right up to where you want it. It's 14.5, very tight as you can see on there, because that is not a lot of deflection at all. At this point, let's assume that you're set there. So you've pushed that in to tighten it. You then tighten up your bolt, take off the tool, rotate it again fully twice, hook the tool back on and check the reading. If the reading's right, then that's fine, you're all set. Tighten this up to the specified torque and you're done. If it's a little bit less or a little bit more, adjust it again, take the tool off, rotate it and check again. And basically you're doing this until the reading on there reflects the reading that you should be getting. Likewise, if it's too tight, then what you need to do is move the tensioner that way, which will move the belt from that position and slacken it off, allowing the scale to move back out. Okay, when you're fitting and removing the tool, make sure that you fully unwind it, so you're relieving the pressure and you're not allowing the spring to snap back out on itself. So you're either winding it right out to the 20 or possibly even the 21. You don't want to unwind it too far because it will come out if you do, and the plunger and the spring will come out as well, and you don't want to do that. And then slip that out from there and then off there, rotate your belt, refit it, wind it back in, and then check your tension setting on this slider. When you're happy with that, remove this. And for storage purposes, what you need to do is rotate this tool out to its furthermost setting, ideally out to 20 or so. And the reason for that is you need to relieve the pressure on that spring. This needs to be moving freely and loosely. If you wind this down until this pin moves right the way down to the bottom, that will put the spring under tension, and over time this will weaken the spring and make the tool ineffectual, and the more you tighten it down, the more under tension it is. Now you can move it just until this pin starts to move, and that means that that bit is free. However, this will leave this sticking out and means it's more likely to actually get pressed in and still be put under tension. So the best thing to do is wind it right the way out to the 20, like so. Try not to go too much further than that, as I say, because the whole thing will unscrew. That means that that's nice and free, the spring's not under tension, and then this is also not sticking out, so it can't be pressed when it's in storage. And that's how you would go ahead and store this device, and then keep that wrapped up and somewhere nice and dry where it's not going to get rusty or what have you, because a tool like that is not the kind of tool you want to get rusty. So there you go, that's how that tensioning tool works. That's how you would read the chart, and that's how you would set the tension. One more thing I need to mention: your typical cam belt thickness is 5mm. So another useful tool is a vernier gauge. Not essential, you can use a ruler or a tape measure just to get your idea, and you're measuring from the top of the teeth to the back of the flat there, so you're measuring across that section there between my thumbs. And if it's 5mm, which most cam belts are, just go with the chart. If it's above 5mm, what you need to do is add however many millimeters above to the result that you need to achieve. So the setting that we needed was 16.6, and the resultant setting was 14.5 on the sliding scale. If your belt was 6mm, you would add 1 to that, so it would be 17.6 and 15.6 or 15.5 or whatever it was. If it was 7, you would add another 1. If it was 8, you would add another 1. If it was 9, you would add another 1. If it was 10, you would add another 1. So essentially, for every 1mm thickness difference, you add 1, 2, 3, 4 or 5 or what have you to the results on the scale that you're measuring, because the thicker the belt, the difference, that there will be more of a difference in the actual pressing force and deflection, because you've got more material to deform. Typically you'll find most belts are about 5mm. Occasionally you'll come across some 6 ones. It's highly unlikely you'll come across anything thicker than that. So just to recap, you convert your Newton meters into decanewtons. So 52 to 57 would become 5.2 to 5.7. You take your average in between. If you can't get a number that's bang on, you go down until it matches up with the across portion, which is the millimeters of deflection, and then you read the 2 numbers on there. The top number is what you set the knurled knob to, and the bottom number is what this pointer needs to point to when it slides up and down the scale, and you adjust that by adjusting the tensioner until it's correct, and then tighten that tensioner down to its correct torque setting, rotate it, check it again. Once you're happy, tighten it to its proper torque setting after that, once you're happy with it, tighten it to its proper torque setting, rotate it again and double check just to make sure, and then reassemble everything and you're good to go. So hopefully for any of you that are looking for one of these tools, this particular one, as I say, is a Satra I got from eBay, and there are ones available by Laser and a few other manufacturers. They are all essentially the same tool. They're quite possibly even all made in the same factory with just different branding on, for all anybody knows. The only real difference with this one is it came in this in a bag and in this box with no instructions, but you can download the instructions online, and of course you can screenshot the instructions as I showed you there and take a print of that. It's a very good tensioning tool. It takes away a lot of the guesswork of doing the whole sort of twist method, or sort of giving it a bit of a press and seeing how much flexibility you think it's got. It takes the guesswork out of it essentially. Very similar in operation to the Facom tool, but much cheaper and a little bit more complicated to use, but provided that you have that chart and provided that you have those two bits of information which you will find in your workshop manual, then you can set the tension for any given timing belt. So I hope that was useful. Thank you for watching, and check back and we'll see you in the next video.